fact that we've got to measure like the length of the eye, the shape of the eye, the distance between all the structures, so that when we do cataract surgery, we take out the natural lens and replace it with a fake lens. And that is the whole IOL master concept is based on, we need to figure out what the power of that lens is, depending on how long or how short the eye is and how much astigmatism they have. So we can fix that stuff with glasses. But when it comes to cataract surgery, we're talking about the power of the actual eye itself. So emetropia, and if you guys are taking your COA or even COT, emetropia is a term you should know, which is neither myopic or hyperopic. They're not nearsighted, they're not farsighted, they're just emetropic. They have a normal eye. There's no need for glasses or contacts. And when we talk normal, just like we say normal perfect vision is 20/20, I mean, everything's relative. But normal vision being 20/20, we're going to consider as a baseline normal eye length as 23.5 millimeters. And when we talk about that, we're talking 23.5 millimeters from the apex of the cornea, right? So if you put this eye behind an autorefractor and you're trying to get that white dot in the middle of the square in the autorefractor, that white dot is the reflection of the highest point of the cornea. So the axial length is the measurement from that highest point in the cornea to the very, very center of the fovea. And if everything is right, it should land exactly there, right? So you've got this kind of bullseye. You've got your rods and cones kind of scattered in this darker part here. This is the edge of the divot in the OCT. And then here's the very bottom of that dip in the OCT, that foveal contour. And this is where most of the cone cells are concentrated. And the cone cells are broken down into those RGB photoreceptors. So RGB photoreceptors being red, green, blue. So anybody who is colorblind, and usually it's not they can't see color, it's usually that their colors are skewed because maybe they for some reason the blue photoreceptors don't work, and so all they get are reds and greens, and they have this weird conception of color. But they don't know it until we test them, because until we test them, they don't know. I mean, that weird
Right.
greenness has always looked like that to them.
Sherry, so this means normal vision, but they could still have problems seeing color?
Yeah, yeah. So not that we're really getting into the color vision thing, but the fovea is where all these color photoreceptors are. This is like when we're doing confrontation visual fields, you've got some people who go, can you see my fingers wiggling? Well, we're looking for rod cells when we do that. Those fingers should be way, way out in the periphery. And when we're testing the cone cells, we're coming in on that visual field so that they can actually count the fingers. And when they can start to count the fingers, that's when they're utilizing those cone cells, the detailed, sharp vision cells. So this is that whole fovea right here. This is the foveal dip in the OCT, right? The whale's tail or the mustache. And this bright layer here is that RGB set of photoreceptor cells, right? They're running along this bright orange line here. So when we're doing biometry, when we're doing IOL masters and stuff, we've got patients with a really long eye. So the cornea itself and the lens itself, they're kind of stock equipment. The stock equipment, and when I say stock equipment, I'm talking about like when you buy a car. You are not going to pay extra for power windows and power steering and cruise control. It comes with the car. It's just that whatever. And you can soup up that car, you can add tires and you can add a better engine, but that basic stuff is there. So the cornea and the lens are built to make a focal point at 23.5 millimeters, right? If you've got an eye and you're doing IOL master and you've got an eye that's 27 millimeters long, the image, the focused image is landing inside the vitreous somewhere. It's not landing on its fovea, right? So if we've got Brittany, I don't know if you guys remember Brittany, who was the recruiter, and then she stepped out for to have a family, but I just thought she was so much fun. And when I first met her, I said, "Oh my God, can I take your picture?" And she said, "Why?" And I said, "You're so myopic." And she said, "How do you know that?" Because if you look at her through her glasses, look at how tiny she is through those lenses compared to the actual size of her face, right? So she's really myopic. She's nearsighted. She takes these glasses off and looks at her phone. She's going to have to hold her. Some of the real nearsighted friends of mine say, "I have to eat my phone to see it." Um, so if she takes those glasses off, she's going to have to put her phone like an inch from her nose to see it, because she needs to take this image that's focused way here in the middle, and she needs to hold it really close so that she can move the image back onto that fovea, right? So when you look through a minus lens, when you look through a minus lens, what it's doing is it's pushing the image away. So if you go to a loose lens kit and you pick up a minus lens and you hold it away from you and you look through it, everything looks farther away and smaller. So if she's got to hold everything an inch from her nose to see it, we put a big minus lens in front of her and it will move it farther away from her. So she doesn't have to look at it up at her nose. When she wears glasses, she can hold it at a normal distance. So if the eye is really long and this focal point is sitting inside the vitreous, what we do is we take a minus lens, a concave lens. So if you're taking COA or COT, you want to make sure it's because it's kind of weird. Like if you overthink it, it's kind of weird. So we're taking a longer eye, we're taking a weaker lens, right? So we're going in the minus direction to take this focal point, spread these rays out, and move this focal point backwards so it lands on the fovea of that, say, 27, 28, 29 millimeter eye. This eye, she's a minus 14, right? So you can really, really see how the minus lenses minify things. They make things look smaller and farther away. So if you guys are refracting and they go better one, better two, and they go, "Oh, I like two," and you give them minus. And better one, better two, and they go, "Oh, I like two," and you give them minus. They're going to keep liking it, especially the youngsters, right? These under 40 people. They're going to like that minus, and eventually, because everything always looks crisp and clear. But if you start to feel like you're over, you're like feeding them too much minus, say, "Does it really look clear or is it just smaller?" And they'll go, "Oh yeah, it's just smaller." And you go like, "Nah, nah, nah, you can't have that minus. That's too much." But for somebody who's super nearsighted, they need that. And then there's this guy, right? So if we back up, myopia, myopic, minify, minus lenses, all these negative, minus, minus, mini, 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 right? Hold it right up to your face. Now we've got hyperope guy, right? So the normal eye length is 23.5 millimeters from cornea to fovea. But if this guy's eye from the front to the back is 20 millimeters, a short eye, right? So Maureen's here, she can tell you the short eyes, right? They want extra special stuff on these short eyes. because what we need to do is take out this cataract lens and make it, like we're going to put a stronger lens in there, because the stronger the plus lens, the shorter the focal distance. So this cornea, this stock cornea and this stock crystalline lens are built naturally to focus at 23.5 millimeters, way back here. So if Mr. 20 millimeter eye looks at something, he's not like the nearsighted person who has to pull the phone up to his nose. He's going to pull the thing farther away, way far away to see it. And that's a pain in the neck, right? So this is our far-sighted person. They see best far-sighted hyperopia, right? Big, far, up, hyper, all those positive connotations. But because the image falls too far. And so for cataract surgery, when you can talk to the scribes in the room, they'll tell you that in cataract surgery that these lenses that the doctor chooses are going to be up in the, they're going to be stronger. They're going to be up in the 20s, the 20 diopter range, as opposed to the nearsighted guy that might be down in the 10 diopter range, right? Because the eye is longer, and so you want to make the lens weaker to make it go farther back. So these are the people that are wearing the plus lenses. They're wearing magnifying glasses. They can't see up close, so they need a plus lens to see well. So what's happening with them is here we've got that 23.5 millimeter focal point, but the eye is 20 millimeters. So we put a convex plus lens in front of it, and for every diopter of plus, right, a 1 diopter, and this is a good COA test question, 1 diopter of plus will focus at 1 meter. 2 diopters of plus will focus at a 0.5 meter, right? So it's a reciprocal fraction. 3 diopters will focus at 1/3 of a meter. 4 diopters, 1/4 of a meter. So as the diopters get stronger, the focal point gets shorter, so that when you start talking about a myopic patient, we're giving them a +10 lens when we take out this cataract lens, right? But if we have a hyperopic patient, we're going to be putting in maybe a +20 lens, a much stronger lens to make this, because the stronger the lens, the shorter the focal distance, right? So when we're putting in, when we're replacing this lens, we're going to replace it with a much heavier plus. And then, of course, what we're really talking about here are glasses, right? So we put a plus lens in front of a hyperope, it shortens the focal distance and corrects their vision. So the plus lens is magnifies. So when you're going to read a pair of glasses, you just hold the glasses out at arm's distance, and if everything's big and blurry, or if they're really strong, big, blurry, and upside down, then you got a plus lens. And if you hold a minus lens out, everything's going to be right side up, farther away, and very, very crisp looking. Then we got our +40, 40 plus patients, where the lens begins to thicken and stiffen, and the zonules can't pull as hard and, do as much pushing and pulling on the lens. And so they get presbyopic. And this is when we're refracting, we're talking about age, add by age, right? So once we're done refracting, if they're 30, we're not going to really refract them for near. But if they're 40, we might. Maybe they need a +1 or a 1.25 add to read, because this is when they hit 40 and they start pulling the book away, the menu away. You go to the bars and you'll see the 40 pluses going, do you have any readers back there behind the bar? Because it's dark and they can't see the menu.
I think that's me, Sherry.
Is that you, sister? I'm sorry.
My arms are not long enough.
Yeah, you got those little T-Rex arms.
Yeah.
And so Etta and I were working together today, and this is what we were talking about when we were refracting for near. we throw 4 clicks of plus in after we've refracted them for whatever we want their prescription, their sphere, their cylinder, their axis. And if they're over 40, we're going to throw, a diopter or so of plus in there to see if that helps with their near vision. And then at 45, we might be putting in 1.5. And at 50, we might be putting in 2. And at 55, we might be putting in 2.25. 60, we might 2.5, 2 3/4. We're kind of running like a half diopter for every 5 years or so. Um,
So
so
I
most,
have an astigmatism, so and my prescription isn't that high. For my contacts, I think I'm like plus 150 high ad for both eyes.
uh-huh. And then you got to consider too, Francie, that if they're contact lenses, do you have multifocal contacts?
Yes.
So for contact lenses, you got to change the ad to a weaker ad because the contact lenses are 12 millimeters closer to your eye than a pair of glasses would be.
Yeah, the doctor took my because I have a progressive. My distance isn't, bad. I have pretty good distance. It's just everything reading the computer, reading a book. It's just I can't see. So they converted my prescription
Hmm.
into the multifocal contacts. So now I can see the computer, I can read. Distance gets a little fuzzy, you
Do you
know.
get little halos?
Mm, not that I've really noticed.
So if you guys aren't familiar with the multifocal contact lenses, what they have are rings. There's ring inside a ring, inside a ring, inside a ring, inside a ring, and every other ring is plus, and then every odd ring, like so it goes plus and then prescription and plus prescription, and it goes all the way in. So and your brain figures it out. It's ridiculous. It's amazing. Um, But because it's a contact lens, it's going to be a weaker plus because it's sitting right on your eye.
Mhm.
So for the COT folks, Duffy and Etta, you guys that are studying for COT, Francie, are you working on your COA, right? And Sue, you're a COA, right? Are you thinking COT or so contact lens conversion for you guys that are going for COT? That's something you want to considered. You don't have to really, really, really learn it, but you do have to kind of understand it, just to get a few of those extra correct questions in there. But what happens is the accommodative power as we hit those 40s and 50s and 60s um, decreases. Uh, about a half diopter every 5 years, and this is where we're throwing those readers on. So if you don't have a big, huge astigmatism, if you have a pretty spherical eye and you're just presbyopic, you can go to the dollar store, and just grab a couple of plus lenses. Um, but if you're astigmatic, right, the curvature of the cornea differs in one direction than the other. Like if you guys look at a topo, it's got those circular lights, um, and the topo shines those circular lights on the surface of the cornea. So if the surface of the cornea is very, very spherical, meaning round, the circular lights are going to reflect back in a circular pattern. If we shine circular lights on a cornea that's more steeper in one meridian and then flatter 90 degrees away from that, that's what astigmatism is. You're going to get this oval shape reflected back at you. And that's when the cornea is not perfectly spherical. So what happens is the flatter curve gives you a longer focal point because it's more minus the flatter curve. And the steeper curve gives you a shorter focal point because it's more plus. And so these patients have difficulty. They're like, well, what's worse? Is it your distance vision? Is it your near vision? Yeah, it's both, right? So that's what astigmatism does. It takes this focal point and it spreads it out. And so they get this kind of smear. And so Francie's telling you she's got astigmatism. She takes her contact lenses out and goes out in the car and drives at night. And when those lights splash, they're going to splash at the angle of that astigmatism. So in this blue eye up here in the top right corner, if you look from the point of this egg shape to the point of that egg shape, like the oval football thing, if we drew a line through them, if this person without glasses went and drove at night, headlights are going to splash in this 180-degree kind of splash pattern. So this is exaggerated because they don't really see double. Well, the cataract patients sometimes you do. I do. I'm starting to see double with my cataract. But you can see that the angle of this astigmatism is going in this direction, right? The lines are smearing up at this specific, like 135-degree angle here, unlike this one that's 180. And so the smear of the image goes in the direction of that astigmatism. So if you think of astigmatic vision, if we're looking at cylinder lenses, this is two cylinder lenses stacked on top of each other. I put a Sharpie on there and did the between the engraved lines on the lens so you could see them. And so I've doubled up. This is 10 diopters of astigmatism at about 135 degrees. That's what a patient would see. It kind of skews that image. If we take these 5 diopters of these 10 diopter power and we split them at 90 degrees apart, you can see that all of that tipped distortion goes away. But we work in minus SIL, so it's still making things look farther away. So when you're refracting, if you add minus SIL, you're clearing up the distortion, but you're making everything smaller, which is why for every 2 clicks of minus SIL you add in a refraction, you want to click a plus on that sphere to bring the size back to the correct position. Did that all make sense? Did I put you all to sleep? I'm sorry. Um, So Rohini, this might be good information for you. This is the eyeglass prescription broken down. So the sphere, we're either moving a focal point closer to the retina with plus, right? So we're correcting hyperopia with plus, or um, we're moving the image farther away with minus, right? So we're correcting myopia with minus. And if they have astigmatism, we're correcting the distortion. And the amount of distortion determines the amount of correction. So we're trying to figure out how wonky is the eye, how wonky is the cornea, and then we're going to figure out which direction it's wonky in, and we're going to find the same wonkiness with the lens, but we're going to flip it 90 degrees away to fix it. And then wherever that angle is that we moved it to fix it, that's the axis, right? So if you think of an axis wheel on the lensometer, right? This is the axis of what we did to fix all this craziness over here. If we look at the add is the amount of magnification we need to do for presbyopia. Let me open my thing over here and make it bigger in the back and open my chat. All right. So pop quiz. Look at the 4th number in this prescription. And what do you think? How old is your patient? You've got a +2 add. How old is your patient? What would you estimate? I've got the chat open, so if you can't talk, you can type. Hi. Anybody? Is anybody listening?
Would they be around like 60?
Yeah, 50, 55, maybe 50. Definitely. Anybody, does everybody see why? Like that kind of 45-year-old, we're giving them a 1.5, 50, we give them a 2, 55, we give them a 2.5, 60, maybe a 2 3/4, maybe a 3, depending on, circumstances and all of that. So thank you, Yvonne. I hope I'm not putting you guys to sleep. All right, so look at this eyeglass prescription. Oops, come back. Look at this eyeglass prescription. We just looked at a +2, so we've decided that our patient's probably 50 years old. But if this is a newer concept to you, uh, is this a hyperopic patient or a myopic patient? Is this a farsighted patient or a nearsighted patient? Good, Etta. Right? Why is it a hyperopic patient? Why are they farsighted? Good, Rohini. They're farsighted because we're correcting them with a plus. And this is a pretty farsighted person, right? +4. I'm expecting this +4 patient, for those of us that do IOL masters, we're expecting this to be about a 20, maybe a 21, 22 millimeter eye. And they've got astigmatism, right? So for the cataract folks or the biometry folks in the house, what's another test we have to do for this patient to make your doctor happy? Duffy. Silent Duffy. Pentacam. Yay, George. We want a pentacam, right? Because we've got more than 1.25 diopters of cylinder. So we want to sell them a specialty lens. Right? So if the nearsighted, the first number in the prescription is going to be minus. If they're farsighted, that first symbol is going to be a plus. The cylinder, if they have astigmatism, their Ks are going to be different from each other for people that understand Ks. Their axis is the third number. It's the angle of that non-spherical shaped cornea. The fourth number is telling us if there's a fourth number there, we're thinking they're 40 or over. And they're going to need additional magnification on the bottom of their glasses for the presbyopia. So if we think of the shape of the cornea itself as a football shape or an egg shape, and you had Myers on your topo that were in this direction, feel free to type or talk. What's the angle of this astigmatism? I'll give you a hint. If you drew a line from the point to the point, what angle are you looking at? The third number in this prescription would be 180 degrees, right? We're drawing a line from the point to the point, straight through at a 180-degree angle. If it was like this, what would it be? Don't be afraid. If 180 is this way, what's this one? Yes, Wendy, thank you. 90 degrees, right? About this. Right? 45. Good. And these Ks are always going to be 90 degrees apart from each other. So what's this one? Good. 135, right? So if you have, if we're transposing and stuff, we're adding or subtracting 90 degrees. If you have difficulty just adding or subtracting 90 degrees, try adding or subtracting 100 and then just adjust it by 10. It keeps you honest. Keeps you from making those snap wrong decisions. Nearsighted or farsighted? Newer people.
Nearsighted.
Yes, right? Because we're correcting with minus. Do they have astigmatism?
Very little.
Very little, left eye only. So for the newer people that are starting to get to wrap their head around this, if there is no cylinder, there can be no axis, right? Because there's nothing there. This is a spherical eye. It's got that marble surface that's round, 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 round. So, our plus lenses converging, right? Plus lens, you think of it all pooched out, right? It's gained weight. They're converging the light. Minus lenses, they're concave lenses, right? They've caved in, they've lost weight. And so what we're doing, it's really weird if anybody ever wants to go up and look, or I should take pictures of it, but if you shine straight line laser lights through these lenses, when it goes through a concave lens, the light rays spread out.
Mm.
When you shine it through a convex lens, the lines converge, the light converges.
Mm.
What doesn't change? Through the optical center of the lens. If you look through the plus lens, the optical center of the lens, that primary ray goes straight through. If you look at the optical center of the plus, that primary ray goes straight through. This is why pinhole works.
Mhm.
So if somebody's vision gets better with pinhole, it's because we blocked out all this crazy business and we're looking at that primary ray only. We're like, find your favorite hole in that little thing there. And they go, oh, ooh, it's like, woo, it's better. Because we're taking all this extra junk out and all they're seeing is that primary ray. This tells us that they could use a pair of glasses. This is also the premise of PAP, right? Potential acuity pinhole when we're doing a cataract evaluation. And the cataract's so thick and dense that we light the crap out of a near card and do a potential acuity pinhole. We have them hold up the pinhole, light up the card, get the muscle light right up on that near card. And if they can see those numbers as you go down through the pinhole, we know that retina is working. We know that the cataract surgery is going to help them. And if it doesn't make it better, we might do a B scan. Does this make sense?
Yes.
Good. Prism. Me and Etta were playing with refraction today with a couple other folks that were there. And one of the very important things of setting up the phoropter is making sure that the pupillary distance is correct. Levers are out, pupillary distance is correct, so that the patient's looking through the optical center of the lens, like we were just looking at, right? So if we back up, right? If the PD is incorrect, they might be looking through this part of the lens over here, right? Or this part over here, PD is too close, or vice versa. And so these are the people that send their glasses back because we refracted them and we didn't fix the PD on the phoropter. So when we're sending the glasses back, the first thing I do is I go, well, who refracted them? And I will go look. So hopefully it's not you. So Prism is going to move the image. So we can make sure that the patient is looking through the optical center of a lens to make the image look straight ahead, right? And here's my little Miss Callie Wally. She was on the desk earlier. This is her baby picture. Isn't she cute?
Oh.
If you view through a prism, you get a virtual image, right? So you get a virtual image is displaced in the direction of the point of the prism, right? So if the real image is here, the virtual image is going to be up towards the point, right? So we're always going to, because the light ray is going to bend towards the base of a prism.
Mm-hmm.
So if we've got a patient who's got double vision, we're going to make them look through a prism on purpose. So if they've got double vision, usually it's a misalignment of the eye or a muscle imbalance. It could be from a palsy, it could be from a stroke, it could be, a kid that was born with an eye turn or whatever it is that caused the problem. But if you have a muscle imbalance and the eyes aren't aligned correctly, you're going to have one of two things. And this is a question that's on almost every certification test I've ever taken. If your eyes are misaligned, you're going to have one of two problems. Can anybody know what those two problems are, or at least one of them? Feel free to write.
Sherry, I have a question because this is actually came up when I was doing a visual field for a patient, and they were explaining to me that they wear a prescription for prisms. So when I told them to look at the yellow light, but they're trying to explain to me that the yellow light is either to the left more or to the right more. And even though I'm putting in the prescription that's in their chart, it doesn't help because it doesn't have a prism. So
Right.
when,
Interesting.
when you're doing the visual field, I'm like, well, like, am I telling them to look at the yellow light where they see it, or what I told one patient, because they said it was very far right, I said, just look straight, because that's the only.
That's really interesting. So what she's describing for everybody that's listening, right? Pick a spot on the screen and look at it. Like look at Callie Wally over here and look at one of the kitty
Mhm.
pictures, right? If you guys look to the left, the image of Callie is going to appear to shift to the right. It's not going to be in focus, but you're going to see it shift to the right. If you look to the right, the image is going to appear to shift to the left. So this patient that Francie's talking about has an eye turn. And so the direction that eye is turned, right? If that eye is turned, like if it's my right eye, and I got to cover to make sure I tell you the right thing. If my right eye is turned nasally, the image is going to shift temporally. So when she's telling the patient to look at the yellow dot that's straight ahead, it appears to this person, depending on which way the eye is turned, to be in the opposite direction. The amount of the eye turn. Francie, do me a favor.
Mhm.
I don't know the answer to that question. I'm wondering, do we put, I would think the answer would be to put the person's prism correction in there, which means you would have to take the plasma lens out, put a manual arm in.
I mean, most of the time I have to do that. Like I have to use the manual lenses, but I don't know. According to the
You'd have to, if it was more than one diopter, I would think that you would have to put in the holder.
Mhm.
You'd have to go into the loose lens kit and there's a prism section in there. I think it goes up to 3 or 4. It depends on the kit that you have.
I only have the general kit that has the minus this for the sill and the axis. I don't have anything special that's for prisms.
Do me a favor, ask an optom,
Uh-huh.
ask a doctor.
Okay.
Find out, research that for me, because I honestly don't know the answer. If it was me and I was like, oh my God, I'm the only one in the clinic and I'm doing this thing and I don't know what I'm doing, I would probably grab a loose prism and throw it in there to try and center the image for them.
Okay.
But I'm not sure I'm not 100% sure that that's a correct answer. That's just my gut feeling. So look it up for me and let me know so that I can correct myself if I'm wrong.
Okay.
Thanks. Um, So the answer to my original question is if a patient's got an eye turn, they've got one of two things. And any of you guys that are taking the COT, the answer is they either have diplopia, right, double vision,
Mhm.
or what? What happens to the eye that doesn't get corrected?
Amblyopia.
Amblyopia, it shuts down.
Mhm.
Right? So they either have diplopia or suppression, right? The brain suppresses the weaker eye, which is why they put the patches on the strong eye of the little kids to make that weak eye do its thing. So if they've got double vision, say we've got a patient with a nerve palsy, third nerve palsy, sixth nerve palsy, and they suddenly come down with double vision, that double vision is going to be very disconcerting. It's going to throw their balance off. And if they've got something going on like that, I'm sure they've got a boatload of other problems too. So we're going to give them, a lot of times we'll give them something called a Fresnel prism,
Mhm.
like those stick-on things, temporary prism. And what the prism does is if we put it over the deviating eye lens, right, we put the base in, right? This eye is pointing out, right? So we would put a base in prism and move that stuff over. Look at this is upside down. Holy crap. Hold on 1 second. I'm going to fix that right here, right now. Screen sharing is stopped. I know that. I just need to look at this for a second because this needs to be here. Base in prism. Oops. Just fixing my prism picture here. You can, and then I need to reshare. Hold on. Screen one. Good. You can see this, yes?
Yes.
All right, good. So when we have this eye that's turned out, right, it's got an exo deviation, we're going to point the point of the prism in the direction of the deviation, and it's going to shift the image towards the base. And it's going to take these two images and shift them together so that the patient now has stereo vision and it's not double. So they can fuse the image. So one diopter prism is going to shift that image in the direction of shift the image 1 centimeter at a distance of 1 meter. 2 diopters are going to shift it 2 centimeters at 1 meter. A 3 diopter prism is going to shift it 3 centimeters. So the bigger the shift, the bigger the prism. You want to do the little quizzy? Let's do the little quizzy. Can you still see that?
Yes.
Okay.
Do you want us to write it or?
You can, let me open up find my chat function again. Hold on. There we are.
What do we, just to you?
Yeah, just toss it right out there.
I don't want to,
All right.
people do it.
I've got a vote for D. Anybody
Mhm.
disagree with D?
Yes.
Right, that's correct, right? A concave lens, minus lens, minifying. caved in, so thinnest at the center. Minus, minify, negative, right? Good. Convex. What do you got, Rohini? Good. Good, 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 good. Convex, right? Convex. It's
Mhm.
gained weight. It's a magnifying glass. It's thickest in the middle. It's a plus lens, makes things bigger, makes the focal point closer. Good. Prism.
Oh. So,
Throw them on in there. Good. Got a lot of, it's making me realize I had three things in a row that the answer was D. So good. The prism glasses are going to shift an image to correct double vision, and there's going to be a wedge shape in the lens. There's going to be a thicker side and a thinner side so that the image shifts towards the base. Stronger the plus lens.
wait a second. This- Wait a minute. Now, does that mean the shorter the eye or the longer the eye when you say the
Well, the stronger the plus lens, so it could be the eye, that could be the lens inside the eye, it could be a lens and a pair of glasses, it could be a loose +1 or a loose +5,
right,
or a pair of reading glasses +3.
right.
Yes, Rohini. Getting it. Getting it. So stronger the plus lens, right?
Hmm.
What?
The focal point falls behind, make the eye is shorter.
So it's we're creating a shorter focal distance for the shorter eye, right?
Okay.
So the stronger the plus lens, the shorter the focal distance. So if I need a pair of +2s to read the menu right in front of me here,
Mhm.
but I wanted a pair that worked really good with my computer, which is actually 2 feet further away. My computer monitor is way back there. Do I need stronger readers or weaker readers?
Weaker.
Yeah, weaker readers, right? To
Mhm.
lengthen that focal point, and the stronger they get, the closer the focal point gets.
Okay, I just couldn't, when I read it, I don't like.
Yeah, and this is why I like doing questions like this, because it makes you look at it as if you were, you were going to take one of these certification tests.
Mhm.
So a prescription with no cylinder.
Sorry,
See,
I don't understand.
Oh, that was my phone. Siri's confused.
yeah, see,
Okay, I found this on the web for how my phone series confused.
Mhm.
Siri just found a something on the web about why Siri's confused. That's pretty funny. All right, I'm closing you down here, kid. All right. So let me look and see what we got. C, senor.
Mhm.
Right? Prescription with no cylinder has no axis. Why? Because it's spherical. No matter where you measure those Ks are going to be the same if it's a spherical image. Cast your votes. If a lens is sphere only, and the way, and sometimes those ones with the little itty bitty cylinder, you're not quite sure, and I take that axis dial and spin it to make sure everything looks exactly the same.
Mhm.
That's right, and a better. Good. If it's sphere only, all the lines are going to be in focus at once. And if you spin that axis wheel around, nothing's going to change, right?
Mhm.
Cylinder lens. Good, Rohini, you're getting it. Cast your votes. Don't be afraid. Power only in one meridian. Now, here's a bonus question. Here's a bonus question for George. George, if my axis in my prescription is 180,
Mhm.
what is the axis of the meridian that has power?
90.
Yes, ma'am. Me and Sue fought over this test question for about 3 weeks back and forth on email.
Well, that's so funny.
But she has it now. She owns it now. An eye with an astigmatism will have what? I like putting the votes in the chat. I like this. Right?
Well, how do we know? Is it just astigmatism or is it?
Well, an eye with an astigmatism is going to have, if you do the Ks, right? If you measure the cornea from the flattest meridian to the steepest meridian, and those are always going to be 90 degrees apart. If those two curves are different,
Mhm.
steeper curve is going to have a shorter focal point. Flatter curve is going to have a longer focal point, which tells you what? That there's more than one. Which is why you can't correct an astigmatism with sphere lenses. You have to have
Right.
a lens that's got power in only one direction, and then you got to figure out what the axis is so that you can get 90 degrees off it to fix the distortion in the middle. A one diopter lens will focus light at
Mm. G as in dog. That's
anybody disagree
pretty big.
besides me?
Yeah, I thought it would be millimeter, like 3.
So don't one diopter lens, not a one diopter prism. Right? Good, Etta.
Mm.
Right, a one diopter lens, a +1 diopter lens is going to focus light at 1 meter. Two
What?
diopter lens is going to focus at a half meter.
That's a meter?
Yep. So if you took a 1 diopter plus magnifier, you could hold it like 3 feet away from the paper and still see the paper.
Okay. I'm
But if you took a 2 diopter lens and looked at a piece of paper, you'd have to move closer because it's stronger.
okay. I'm thinking of see how the
It's tricky. It's tricky. It really is. So it's a reciprocal fraction is what it is. So 1 diopter lens will focus at 1 meter, 1/1. Right?
thought you meant
2 diopter lens is
Right.
going to focus 1/2.
Yeah.
3 diopter lens 1/3. 4 diopter lens 1/4. So as the 4 diopter, as the diopters get bigger, the focal point gets closer and closer, which is why we're doing, you know, a myope, we're correcting with a +10. A hyperope correcting with a +20. Presbyopia. Yeah. Presbyopia is no joke.
D.
Anybody disagree?
Oh,
Right? It begins around age 40, whether they admit it or not. It's due to a stiffening of the natural lens, and it makes you artificially farsighted. It doesn't change the length of your eye, it just changes the amount of accommodation you can pull off. And that be that. And there's my Hodor.
wow, you're beautiful.
Isn't he handsome?
Oh, that's gorgeous.
What a handsome boy.
Oh, pat his whiskers.
So let me pull up my my thing here. I want to make sure that I have everybody. Charlene, I don't think I had you at the beginning. You're still here, right? Charlene was in my class today. Did that go well for you, Charlene? I don't know if she can still hear me.
Looks like her mic's, oh, there she goes.
Yes, it did. Thank you.
You're welcome. Did this help it? Did this pull it together a little bit too? Like make it make more sense?
Absolutely. Yeah.
Great, great. I'm really, really glad. So I've got Suke, Francie, Etta, Wendy, Yvonne, Rohini, Maureen, Charlene. Did I miss anybody? Did I get Wendy? Wendy, yep. Duffy, did I get Duffy? 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8, 9. Good. All right, guys. I will see you next week.
Thank you, Sherry.
You're welcome. Bye.
Thank you.
you.
Bye.
Welcome.